We need to show that cosine of A plus cosine of B plus cosine of C plus cosine of D, the sum ups to 0, and it's given here that A, B, C and D, these represents the angles of a cyclic quadrilateral. So let us begin. Now before beginning, we need to state a fact here that whenever we have a cyclic quadrilateral, then let's say the quadrilateral is named A, B, C, D, then the sum of the opposite angles, that means if we consider A and add it to angle C, then the sum is going to be 180 degrees. So that's for a fact. So I'm representing 180 degrees in radians as pi. Let this be equation number 1. Then similarly, we can also say that the sum of the angles B and D, because they are opposite to each other, so that also sums up to pi radians. Coming to equation number 1, here we have A plus C equals to pi, so we can represent A as pi minus C. So let's take the cosine on both sides. So with cosine of A, that will be equals to cosine of pi minus C. Now pi minus C, we can also represent it as 2 times pi over 2 minus C. So here we have an even multiple of pi over 2. So whenever we have an even multiple of pi over 2, then cosine is going to remain as cosine. So we're going to get cosine, but the new angle is going to be C. We'll also have to check in which quadrant our given angle pi minus C lies. So here we have the first quadrant, second quadrant, third quadrant and the fourth quadrant. So in the first quadrant lies 1 pi over 2. In the second quadrant we have 2 pi over 2. Then we are also subtracting an angle C. So assuming C is an acute angle less than 90 degree, then we can still say that it's going to lie in the second quadrant. Now in the second quadrant, our sine and cosecant function, these are positive, everything else is negative. Since we started out with the cosine function, so it's going to give us a negative value. So cosine of A was going to be equals to negative cosine of C. Similarly, we can say that about equation number 2 as well. So we can rewrite equation number 2 as angle B equals to pi minus D. So let's take the cosine on both sides. We have cosine of B equals to cosine of pi minus D. So cosine of pi minus D, that's going to give us negative cosine D. So here we have obtained that cosine of B, that's equals to negative cosine D. Now we take cosine of A, add it to cosine of B. To it, we are also going to add cosine of C and cosine of D. Now we have obtained that cosine of A, so that's equivalent to negative cosine C plus cosine B plus cosine C. And then we have cosine D, so cosine D is going to be negative cosine B. So all of the terms get cancelled out and this gives us a value 0. So that means cosine of A, cosine of B, cosine of C and cosine of D added to each other gives us a value of 0, where A, B, C and D are the angles of a cyclic quadrilateral.